Hi guys, Mr. Sonnenberg here. Today what we're going to talk about is the particle theory of matter, or what might be known as the particle model of matter as well. So basically we're going to look at the different states, talk about how particles react, and the best example we can use for this, I would say, is to talk about water and it in the various different states as well. So there's 5 components of the particle model or particle theory of matter, and the first that we will discuss is going to be that all matter is made up of tiny particles. So everything that is matter, and remember, matter is anything that has mass and takes up space. So all matter is going to be made up of tiny particles. The second thing we're going to look at is that all particles in a pure substance are the same. So if it's water, that is the pure substance, then all the particles within there are all the same. Okay, it's all water. They're all H2O. Okay. Now, the third thing we'll discuss in the particle model is that there are spaces between the particles. Now, even though a solid, so I knock on this table or I hit this pen, it's solid, doesn't mean that the particles are not moving. They're still moving in here. They're just tightly packed together, and we'll talk about this a little bit more as we go. And then, so there's always spaces. In a solid, there's less space. In a liquid, there's slightly more space, and in a gas, there's a lot of space. But then number 4, particles are always moving. So the particles in here are moving. There's very little space for them to move around, but they're still moving a little bit. Whereas in water, it flows because, well, the particles are farther apart and it allows them to move more freely. Okay. Then the last component of the particle theory of matter is that particles in a substance are attracted to each other. Water binds to itself. Okay, so how do we keep particles in a solid together? Well, they're attracted to one another. They're tightly packed and they're attracted, and that's what holds them together. Okay, but how can we change this? And we'll talk how can we alter something's state as we move about. So the 3 main states of matter are going to be solids, liquids, and gases. So first we're going to talk about solids. So particles in a solid are going to be tightly packed together, and you'll notice that by looking at this illustration on the right. They're tightly packed together. They're still moving. Okay, there's very little space, but solids aren't going to take the shape. They're not going to take the shape of a container. They're going to keep its shape, but they're not going to fill a container. Like if you pour water into a bowl, the water fills the bottom half of the bowl, or bottom portion of the bowl, based on the volume of water you've dumped in. Right? But if you dump, say, an ice cube in there, well, there's going to be gaps in between because it doesn't fill the shape. But that's because the particles are packed so tightly together and they don't move very much. So a solid is going to keep its shape and it's not going to flow. Okay, that's important to know. Now, moving on to liquids. Liquids, the particles are touching, but they can move past one another. So that's why liquids can flow. Okay, so they move past. And what they do is, like I just said, if I poured water into a bowl or into a glass, it's going to fall to the bottom based on gravity, but it's going to take the shape of the container. Okay, so if you just take a look over at this diagram over here, well, this diagram that I'm pointing to, look at how it's taking the shape. This portion of the glass is not full. Well, because the water took the shape of the container down below. Notice that there's not just water that doesn't go in this square right here. All this water fills this whole container. Okay, that's because the particles can slip past one another, and they have the ability to flow. If I drop water, it's going to run away, right? Especially down a decline. Now, gases, the particles are even farther apart. Okay, and they move even faster because there's nothing restricting them. They can move by each other as quickly. So the thing with gases is the particles will keep moving away from each other until they're stopped, say by the walls of a container. So say I take a jar and I put the lid on, well, now there's 4 corners and it's been sealed. That means that the gas is trapped inside, but it's still moving inside, okay? But notice that in the illustration to the right, the particles are farther apart. Now the last thing we're going to talk about is this diagram right here. This is basically outlining that there's 3 states. So we have liquid, like water. We have over here, we have a solid, ice. Then we have gas. So if I was to boil water, okay, if I was to boil water, water would turn into a gas at 100 degrees Celsius. Okay, so anything above 100 degrees Celsius, like 110 degrees Celsius, water is going to be a gas. So what happens is anything below 100 degrees, though, um, is going to be a liquid. So what happens with water is if I lower the temperature and something freezes, then as I lower that temperature, what's going to happen is it's going to turn into a solid, and so that is called freezing. Okay, and you're going to end up getting the snowman. Water is going to turn into ice, and again I'll underline it here. Now if I take this solid and I melt it by increasing the temperature, then again now it's going to turn back into a liquid. Okay, and liquids flow. Remember, solids don't flow, but the liquid's going to flow. Now what's going to happen is if I increase the temperature yet again of this water, what's going to happen is we're going to get this process called evaporation. And evaporation is going to create a gas. And so that gas is called water vapor. So that's going to look like steam or the clouds, things like that. Okay, it's going to go up to the clouds, but it's going to look like steam. Okay, and sometimes you won't even see it, but that is going to raise up until it's cooled and it's going to form clouds. Now, what happens if I cool that water vapor? Well, then I get what's called condensation. And have you ever seen those droplets of water on your window? Say it's cold outside and it's warm inside, and there's droplets of water dripping down the inside of the window. Well, that's because water vapor, because the water and moisture in the house is being cooled by the temperature of the window, and then it's changing states from a gas to a liquid. Okay, so then the last one is sublimation, and that's basically going from solid to a gas, or okay, and or a gas from a solid, either way. Okay, but this is how we could alter. So if I take an ice cube and it's a solid, it's not flowing, it's not taking the shape of a container. If I leave it with heat applied to it, it's going to melt eventually. Remember, freezing occurs, water freezes. I'll just write this. Water freezes after below 0 degrees Celsius. Okay, so below 0 degrees Celsius. Okay, starts to freeze. So now if that water was freezing, or I mean if it was melting because it was above 0 degrees Celsius, then what's going to happen is it's going to turn into liquid water. It's going to take the shape of the bowl. Then what's going to happen after that, if I increase the temperature up to 100 degrees Celsius, it's going to turn into a gas. As if it's at 110 degrees Celsius, it's still a gas. Okay, so that's the particle theory. These are phases of matter. Okay, so this is going to happen not just with water, but also if you take a plastic of some sort, you can melt it if it's temperature, if you reach it to a particular temperature and turn it into a liquid. So we do this with metals, we do this with plastics, we do this with other types of elements as well. Okay, so that's the particle theory of matter. There's 5 components of it. Make sure you utilize this to help you answer questions on your post-assessments. Okay, well, thanks for tuning in. We'll talk to you on the next one. Bye.